I like the size of the stage. This was pretty good. I'm normally talk with my hands and pace a lot, so you'll probably get a good show. I'll probably be the first presenter to fall off the stage of the show so far. Try not to, but you know, just forewarning everybody. All right, see, got some stragglers coming in, but how's everybody doing? Everybody catch the keynote? All stoked for another VMworld? Yeah, that's the response I was looking for right there. That's all right. Well, let's get started. My name is Jonathan Howard. I'm the Director of Technology and Engineering Alliances at Commvault. It's a really nice way to say I get a lot of projects from my boss. You know, hey, why don't you go look at this? And today I'm with
Edwin Galang. So I'm a principal specialist, specialized in virtualization in the cloud. So just an SME for our team.
Ooh. So today we're going to talk about hyperconverged architecture. We're going to break it out into a few areas. We're going to break it out into what we're seeing as trends because, as you know, Commvault is not a hyperconverged infrastructure partner, but we do protect a lot of it. So we're going to break it up into three sections. Basically, what we're seeing as trends from all of the vendors, what we're seeing as challenges, and what we're doing to respond to those challenges. I think we're basically going to wait to questions at the end, and I've been asked if we can, and since the session is being recorded, profanity to a minimum, of course, or, you know, at least walk up to the mic before you're going to swear at me, so it's all can be recorded for posterity. Thanks. All right, obligatory forward-looking disclosure statement. Everybody, of course, can speed read that really good, okay? A couple of things we're talking about today have not quite been released, so basically there are a couple forward-looking statements. They're right around the corner. So legal, of course, wants me to make sure I have the slide. Now, hyperconverged infrastructure. See, almost fell off, did it? Right there. All right, let's start with a quick review. You all should really know that we're talking about infrastructure types. But one thing that I always like to talk about is when you start going from the traditional stack to the converged stack to the hyperconverged stack, a lot of people's graphics seem to eliminate one point, which is they say they converge networking. They really converge the storage networking. You need a heck of a lot of networking to pull off hyperconverged infrastructure. Now, hyperconverged traditionally, as we see it, right, it typically takes VM workloads. Now, more applications are being virtualized and more applications in critical infrastructure, so that's really not a big challenge. But the traditional stack versus the converged stack, everybody likes to talk about how there's this expansive growth. I think in the next slide coming up, I'm going to be saying it's 65% compound annual growth rate. Well, that's true, but there's still tens of billions of dollars spent in the other two infrastructures, and that's something that we have to keep in mind throughout this presentation on what we're talking about. Now, the hyperconvergence, you know, how many people in this room are already using hyperconverged infrastructure? I'm hopefully going to see a heck of a lot of hands. All right, maybe a third of the room. How many people are considering it? All right, that's more like it. I remember I was talking with a CIO, and he basically said there's only one reason that I really want hyperconverged architecture. And he says because I have one person who can do everything for me. One person, as long as they can lift 50 pounds in the data center, use a screwdriver, they can absolutely do everything. That's the promise that's being sold to everybody. I see I have a couple of war wounds already. Excellent. All right. When we're talking about the architecture evolution, everybody likes to talk about the compound annual growth rates, where we're doing, and it's estimated by Gartner that by 2020, hyperconverged architecture will outpace integrated stacks. Okay, sure. But if you look at the marketplace as a whole, there are very big things that are missing here. Software as a service, platform as a service, infrastructure as a service. Everybody who's offering cloud and other opportunities, that market dwarfs hyperconverged. How do we integrate all of that together? And what will hyperconverged evolve to in the next 3 to 5 years to meet that challenge, to meet that need? Now, I've actually had this graphic up once before for an entirely different use case, but the interesting thing is it resonates extremely well here. What we find from our customers that are either contemplating it or using it is hyperconverged architecture is easy to get into. But the hyperconvergence of staff is usually the next thing that happens. Right? I'm speaking with a lot of customers who used to have dedicated teams for security, for storage, for networking, for storage networking, for applications. I'm seeing a whole industry trend of saying, I would like an IT generalist. No, they don't. They want an IT generalist who happens to know everything, right? And so there are a lot of elements that hyperconvergence helps. It is really easy to deploy. I think right now there are 17 or 18 hyperconvergence vendors that we're working with, right? So I can't give you a one-size-fits-all, everything's going to work this way, because everything's implemented differently. But what that vendor will give you and how that experience will flow is the key point when you're basically considering any hyperconverged infrastructure. What are you using it for? What is the security that you want? Right? One of the things that we're seeing is we're seeing a lot of people moving into the second bullet to say hyperconvergence is going to replace storage networking. They're going to replace SAN arrays. Now, whether you agree with that or not, right? The thing that we're seeing is I'm going to provide NAS. I'm going to provide block storage out from my hyperconvergence out to other infrastructure. So now, if you're in that I'm hyperconverging my staff, you now have to look at, well, now I'm a storage admin that's providing storage for entirely non-converged workloads, right? What about all the security, the disaster accrual? Everybody likes to talk about agile and DevOps. How do I accelerate and shift the business? Most of the people, when we're talking about hyperconvergence, the architecture is the easiest thing to do. It's shifting the way the business works to do that old adage of more with less that really becomes key. The second biggest point, networking. And most of the vendors that we talk to and most of our customers who have deployed, networking is the least converged component. And I'm not talking about inside the virtual component. I'm talking about the actual hardware component. We are seeing massive amounts of bottlenecks from our customers when they're trying to put this up to what they would say some legacy arrays sometimes. Now, scalability is focused typically on CPUs and storage. Customers who are successful here are really deploying dedicated 10 gig infrastructure at scale on the back end or higher to keep that storage. There's a conversation on, depending on what hyperconverged architecture you're looking for, should I look at replication or should I look at aggregation? Which is the difference is basically saying, well, it all comes down to what you're actually trying to achieve and how efficient that vendor is. I've seen some vendors where they replicate basically the majority of the data across larger pool sets, and then they rely on deduplication and compression to lower the storage footprint back down. So they're replicating the data. Other vendors are focusing on erasure coding. Now, erasure coding, if you're familiar, or even if you're not, it's sort of like RAID. I'm going to put bits and chunks of data all over the place so I have resiliency, right? But when I need to read that data back, the larger the data set that I have to read back, the more it's strewn across multiple different nodes, the more I'm relying on traditional networking infrastructure to gain access to that data. And that's one of the areas where we continually get punished, is in that last bullet. Is what about high I/O applications and large data set reads? I can't think of a larger data set read than backups. There's an old conversation that continually comes around that no matter what infrastructure you're talking about, what new age technology, if you want to find out where it's going to break, back it up and then restore it. And as long as you can do that, you got some pretty good technology. This, we see a lot of complications from our customers with. Network bottleneck speeds, dedicated infrastructure, dedicated nodes. Last but certainly not least, scalability. Now, depending on the vendor that you choose, scalability might be built in. It pretty much should be built in by definition. The challenge that we see is not everybody is scaling equally. Now, why this matters to us, or why this matters in the industry, is it all depends about your storage footprint versus your compute footprint. Are you independently able to scale up every individual component? A lot of vendors will start nodding and saying, yes, of course. Can I performance scale? Can I add local cache and flash to increase my reads? Because going back to the previous slide about the network bottlenecks, what did hyperconvergence start very, very well? What was one of the great first workloads they took on? Why'd they do so well? Everything was deduped, right? If I need to load up 5,000 virtual machines from the same image, that's really not 5,000 VMs from my perspective. Because we advocate, why bother backing up 5,000 stateless VMs? Like, I'm sure if there's a sales guy in the room, he'd basically, because I want to sell it to you. But from our perspective, it's the same information. So now when you start saying, well, hold on a second, I want to put an 8-node Oracle rack inside of a hyperconverged infrastructure. I want to put Hadoop inside of my hyperconverged infrastructure. The performance scaling becomes massive. And these are the conversations that we're starting to have with customers as VDI has turned into tier 3 and dev test and tier 2. And now people are saying, I want to deploy my infrastructure inside of it on my journey to hybrid IT in the cloud. How do I do that? And we're seeing a lot of these scaling challenges be glossed over. And again, the devil you know. Come back to backup, we'll usually help you find some of these things. Now, efficient resource utilization. On storage, there's 2 main storage paths. First one I'll summarize as hypervisor embedded storage, HES, example would be vSAN, or VSA, virtual storage appliance, Nutanix, external, when you're running on VMware. Now, I'm not going to get into a religious debate on which one's better or which one's worse, because I've seen across multiple different vendors extremely efficient VSAs that can do millions of IOPS and do all these great, wonderful things, and customers love them. On the same respect, I've seen extremely inefficient VSAs that will consume 8 cores and 300 gigs of RAM on a 3-node cluster. Effectively, for a medium-sized customer, eliminating any helpful benefit of hyperconvergence in any way, shape, or form. So when you're looking for scalability, you're looking for the performance, you have to make sure when you're comparing apples to apples, what are you actually comparing and what are you doing? Right? And last, but certainly not least, when you inevitably lose a node, and you will, what impact does it have on your organization? Are you running at 100% or are you running at 70? Can you take the hit without actually taking the hit? Data resiliency is not data protection. Now, there was a conversation about the fact, like the cloud is, I have 9, well, I don't think AWS can say that right now, but I think it was 9 nines of availability and resiliency and redundancy. Yes, but that doesn't mean your data is protected. You can lose a node, but what you can't recover from is the large failures outside of your control. The majority, Edwin, I believe you got a slide on this later, but the majority of, if I break it into 2 buckets that say actual equipment failure relating to IT, the hardware failure is the lowest and smallest point. It's everything in the data center that is taking you offline. And as you know, with virtual infrastructure, everything that you're running in memory, if that simply goes offline, good luck to get that back. You better have something. And if you lost the site, how are you going to get all that back? Now, a lot of the hyperconverged infrastructures, they have a cloud connector. Devil in the details, some of them, or I think most of them, require that you have to have that infrastructure to get it back online, or like for like. So if you're in a downtime situation and you only happen to have the cloud, how do you get it back up? Can you? These are questions and considerations when you're deploying hyperconverged that you do it. Plus, our customers are talking to us about everything else in the industry. What about long-term data protection? I mean, one of my favorite ones is one of our customers has a 99-year data retention policy. And you know what they still use? Anything past year 3? Still including all the hardware refreshes and going from LTO 7 to 8 to 9 and all factoring that in for their retention cycle. And it is extreme. They're an archive company, like actual physical archives. So from that perspective, it makes sense. But if your retention, it's like I'm consuming local hyperconverged storage, which has a cost per terabyte higher than cloud or regular disk or anything else. So using that to store long-term data doesn't make sense. It'll cost your infrastructure way too much money. Plus, we're kind of in the golden era, if you will, of hyperconverged vendors. Within 3 years, they're going to start consolidating down. Maybe the vendor you're considering today that has the best technology for your company, or the one you're using, won't be around in 3 to 5 years. Right? If you're using long-term retention there, right, how do you get it out? What do you do? Of course, disaster recovery to the cloud, and let's not forget alternate hypervisor recovery. Right? All factors. But What about data management? How does that change? Right? Here's an interesting example. This is from a usage survey we did, and 59% of the data that our customers were responding to was files. Not VMs, not databases, files. Does that mean they're protecting VMs with file system agents? Okay, maybe. However, let me give you an example in reverse. Hadoop. So Hadoop and VMware, or virtualization in general, are similar in two key characteristics. Do you ever protect the ESX server itself? Why would you? It's transient. You lose a node, you bring up a new node, you do whatever you want, storage, vMotion, move the VMs around, you never protect the ESX server. Well, the same thing with Hadoop. Hadoop, we've got customers, hundreds, thousands of nodes, and the minute you fail a node, it self-heals. So if I protect a 200 node Hadoop infrastructure or a 1,000 node Hadoop infrastructure, I have to bring it back as a whole. That's a very limited use case. So most of our customers were looking at it going, I don't need Hadoop protection. Well, that sounds like a very familiar argument. Hadoop has one other interesting byproduct. You give it 100 terabytes of data, it creates 300 terabytes for you. It's very nice. But our customers are looking at it from the same perspective saying, I don't care if it's physical or virtual. I need the data inside of it. That's all I'm concerned about. Maybe in a VM, I need a directory. Maybe I need the database. Maybe I need the infrastructure inside of Hadoop, now it's virtualized. But I don't need the machine. Right? There are so many great deployment utilities that will auto-refresh and upgrade the actual application operating system and fully patch it for you. If you're always focusing on VM level protection, you can be missing some of the key strategies that are out there, right? Focusing on the data, the application, and the VM if you need to, right? These are all considerations that you need to look at. And for us, the workload is kind of irrelevant, right? You know, when we start talking about efficiency like deduplication and incremental forever technologies and all these other great things that you could bring to bear, the container itself is not really the conversation anymore. It's always about the data footprint and what you're trying to achieve. Now, the NAS and NDMP one is interesting for the simple fact that most of the new hyperconverged vendors' NAS, they don't have NDMP. So how are we going to go and protect that data? I'm not saying, don't get me wrong, I'm not advocating NDMP, but there are considerations to be had about the entire hyperconverged infrastructure. But if you're looking at hyperconverged infrastructure, let's take a look at what we see a lot of customers deploying, and that's traditional data protection, right? They always focus, or not always, they focus a lot of the time on modern infrastructure for their data center, for that software-defined world, but then we get to the traditional data protection infrastructure. And I'm going to include everything, because to me, everything could be virtualized. It really doesn't matter anymore. You know, whether this is VMs, files, applications, big data, end user information, all of it. We're still seeing a lot of customers with dedicated purpose-built backup arrays in a scale-up fashion that you're stuck in a forklift upgrade for refresh and recycle, where the promise of hyperconverged allowed you to eliminate that entire conversation for your VM and your production infrastructure, but in your back end, you're stuck in a refresh and recycle, right? You've got media servers, sometimes you need external tape copies that you can't do directly, and then you need a cloud gateway to stitch it all together. And of course, unlike hyperconvergence, you're dealing with multiple different consoles, multiple different products, or you're integrating it yourself. Well, what happens if we just extend the data center transformation into data management? What happens if we take those same rules, minus the virtualization stack, and look at it from our perspective? You know, what happens if you have a solution that's built on general purpose hardware? I mean, I could sit here and poll everybody and say, I wonder which server vendor is the server vendor of choice in this room, but if I list 6 or 7 of them, I'll probably get to close to 85 to 90% of the room. So take general purpose, good quality server hardware, add software definition with self-healing, self-service, auto-expansion that's distributed and has a rich API feature set. And let's marry it to the actual architecture that you're trying to use in production. What we think we come up with is Commvault's hyperscale architecture. It's a software-defined stack that allows you to start small, deploy across multiple nodes with resiliency, and change the entire infrastructure story to allow for a single framework for deploying and configuring entire hybrid environments. And what we mean by that is, let's stop focusing on backup and recovery. Let's focus on the SLAs. What do you need to provide to the business? Do you need to recover all of your data in 1 hour, 4 hours, 12 hours? Let's stop talking about backups and recoveries and start focus on what you need for the business to succeed, right? And then let's take a component and talk about access, right? Do you need to recover everything, or do you just need to access it? Do you just need to test boot that VM to make sure that it matches what was in your protected stores? Now, this framework, built on these general purpose devices, it still has all that Commvault comes to offer, but you simply get to deploy it. And the great thing here is that you deploy across multiple generations. If you're using HP today and you want to use Cisco tomorrow, great. If you're using Broadwell today and you want to use Skylake's architecture tomorrow, great. It will fit together, it will seamlessly expand. And the other thing is, no forklift upgrades. You've lived out the life cycle of those 3 years of that hardware, or 5 years. Simply, you can turn that off and you can auto expand, or I'd do it the other way, auto expand to the new stuff and then turn off and flush out the old. You don't have to forklift upgrade. And this is where we steal a little bit, if you will, from a software-defined storage conversation, is you're not buying this every time. You're buying the hardware whenever you want to refresh the hardware. You simply have our licensing and you move forward. That's, of course, on perpetual subscription. I can talk to you about all that stuff. But this is where it all comes out. All of it is defined and managed from one general console, one general framework. Right? Access to the cloud directly. Of course, with our orchestration, be able to live access or cross-hypervisor recover or replicate or do any number of other very interesting things, but also focus on protection SLAs in the cloud instances, bring them back, and eventually, if you need to, bring it back on site. We're really looking at a hybrid IT scenario from our perspective, where we're seeing a lot of customers who are trying to deploy specific workloads on-prem and being able to migrate them back and forth. And we have a slightly different take. We look at the data itself as one of the critical infrastructure paths that sometimes can hold people back, right? If I need to take 100 terabytes and move it to the cloud and back again, but it's the same data, or it's dev test promotion, or it's any number of other user acceptance testings or patch testing or any other things, moving that raw data up there for a one-time event, probably not the best strategy, right? To really enable a hybrid IT conversation, to be able to float back and forth. And we want to integrate with as many different vendors and tools as possible, because we know we're part of your platform, we're part of your infrastructure. So before I head over to let Edwin have some slides, basically one of the other things to keep up is, and I haven't touched upon it in here, but that doesn't mean that we're shying away from some of our other items. So on the left, our IntelliStep technology. If you're not familiar with it, it integrates with, I believe, over 275 different storage arrays for snapshot control. And it does integrate with hyperconverged vendors, the likes of Nutanix, and we're expanding that. Because snapshots and storage integration makes a great first line of defense. And especially if you want to use it for some elements of dev test and other elements, being able to snapshot and access that data directly from the storage infrastructure has definite merits. So we're expanding there. Our open systems architecture, we pretty much today run on everything. So although we have our newer hyperscale architecture, if you have existing infrastructure and scale up, and I was talking to a customer and I really want to go shop in their closet. He found 900 terabytes of Isilon. I'm like, okay, like literally, yeah, I've got one in the closet, how about I use that? No problem, we support that too. Our new hyperscale infrastructure goes across the majority of vendors with reference designs that you can simply deploy and use, or you can roll your own. And last but certainly not least, is hybrid cloud integration. Eben?
Great, thanks. So focusing on hybrid IT protection. So Jonathan talked about, you have the data resiliency built in, but what about those errors that occur in your environment all the time, right? Someone logs into a database, they thought they were in development, go in production, and they delete data. Happens all the time. When I was an admin, someone wrote a rogue script to start deleting things. How do we protect ourselves against that? Those things, disaster recovery, site loss, and how to manage that data very easily. And how do we address that at Commvault? Is we address it with our admin console. So we simplify that data management and reduce operational overhead. So we have a HTML5 web-based console that allows you to easily manage, monitor, and report on your hyperconverged environments. So it's a single console, very easy to use. It has sophisticated data protection, whether you have to protect it at the VM, at the data store level, or at the server level. And then recovery, right? How to recover the data, guest files, recovery in VM files, data stores, disk level, or at the VM. And the other part too is going back to the graphic that Jonathan talked about is now we have more hats that we have to do every day. So it gives you the ability to do self-service to your end users so they can recover and also protect their data if they're doing patches. They can run an ad hoc backup or recover it on their own. And then with our dashboard, it provides an at-glance view to manage your data. So you can simply come in, see what's going on, do your day-to-day management of the data, and then also kind of figure out what's going on. And so this allows you to easily manage in your data, your environment, but how do we manage the data? And what we do is with SLA-driven protection plans. What that provides is an ability to easily create and reuse protection plans that you can create that meet your business SLAs. Because we know in our data center, not all data is created equal, right? We have tier 0, we have tier 1, tier 2. So what it allows you to do is with these protection plans is create different tiers of data so that you can meet your SLAs depending on what they do. And with these protection plans as well, they allow you to easily tier the data to different locations, right? We know that some data only needs for maybe a week, other data maybe long-term, 99 years. Within these protection plans, you can easily tier the data to the appropriate tier when necessary. So, maybe you do 30 days on-prem, 31 to 90 days in the cloud, move it to a different level of the cloud, all within these protection plans, and you can reuse them and administer them very simply in your environment. So here, we do a quick demo. It comes up. Just showing how easy it is to use our admin console. So here's your dashboard. It gives you a view of your environment, your hypervisors. The first thing I'm going to do here is click on my targets. So it allows me to have multiple targets depending on the data, right? Every data is different. So I have AWS, S3, I have Azure Blob, but I also have on-prem storage. Depending on the application, I can use those tiers that best fits my business needs. And what we also do is we integrate with all the cloud vendors, the major cloud vendors, natively. So we don't need the requirement of a gateway. So you can easily create different tiers, disk, cloud, and tape in your environment. So when I click on the cloud, very easily I select the cloud vendor, go there, put in my credentials. I have multiple cloud vendors that we support, all the major ones that are out there, obviously Azure, AWS, and Google are probably the top. But there's many different cloud vendors that we can use in order to write your data to. Then once we do that, we create our targets. This is where we're going to store our data. Then we look at our pools, and this is where we leverage that target, and we use deduplication and compression to save you kind of that long-term data for the thing. And we click on here. I have AWS storage pool. I can go into the details, see how much data is protected, and what my deduplication rate. So simple, very easy to use interface that kind of gives you a very good idea of what's going on in my environment. And I can quickly select a storage plan, a storage pool that I can do disk, cloud, or tape. So once I've done my pools, my target, this is where we leverage our protection plans. And here I have multiple protection plans because, like I said, not all data is created equal. So what I'm going to do is I have my tier 0 application that needs 4-hour SLA, maybe another application needs 12 hours or 24. So it gives me the flexibility to have multiple protection plans that I can easily deploy without having to think about it. So all I do is create a plan and deploy it for the application or the VM that is required. And when I select on the plans, it gives me the idea of what's in the plan, who created it, where the tier of data is going to, my SLA, what I have here is a 24 hours, and then in this case I have some replication. So it simplifies that management of the data to both backup and recover. So when I go back over here, I have the ability to, when I create a plan, very quickly do either a backup or backup and replication. So this kind of transitions to what Jonathan's talking about is what about disaster recovery? Don't forget about disaster recovery. We have that data resiliency, but disaster recovery is essential to all businesses. We all know that, but it used to be for the enterprise only, right? It was very expensive to do, very cost prohibitive, but today we have so many choices and so easy to do. And if we look at the traditional cases on that graph on the right-hand side, they haven't changed. UPS failures, we unfortunately see that all the time. When I was an admin, we had someone testing the data center to go to a generator, but the UPS failed. So our servers didn't like not having power for 10 seconds, right? Happens all the time. So it's still, if you look at from 2010, it's still one of the main causes of errors in our environment. And kind of what Jonathan touched about is we build for this resiliency for IT failure, 4 to 5%. It's a very low-hanging fruit that it's kind of built into everything now. But if you look at the other top 3 is user error, right? It happens all the time. People say, oh, I don't know what happened. You start talking to them, well, I logged into the wrong database, I think, and I run the script. I don't know what happened. That happens a lot. And the resiliency doesn't help you there, right? And the big one that we saw grow is cybercrime, right? All over the news. I think they addressed it obviously in the keynote of how do we have cybercrime, it's locked our systems, now we have to go to a disaster recovery. And the other thing too is there's new ways to implement our DR now, right? Back a long time ago, storage background is like to like it was, and it was all or nothing. Now with the new types of things that we can do is you can do different tiers, because like I said, not only in backup, but in DR, not all data is created equal. So you can tier your different applications based on RPO and RTOs that you can implement in your environment. So leveraging those protection plans, you can back up data that only needs to be on-prem, but also replicate that data that needs to be critical and give them different tiers. Tier 4-hour RPO, my DR side, 12-hour, 24, or a week. And kind of transition to what we do. What do? We allow you to do DR to on-prem if you have your own data center. But we also support VMware, VMware Cloud on AWS, but also to AWS and Azure. So we're doing that transition and migration to the cloud provider of your choice. And that also helps in terms of long-term growth. If you're going to do a multi-hypervisor vendor strategy, which we see a lot of customers doing, you're doing it in the cloud. So don't forget disaster recovery. So this next demo kind of talks through leveraging the admin console. We've created our plans. So once we do that, we go to our dashboard, kind of get a view of our environment. And in this one, I have 7 hypervisors. When I drill down into my hypervisors, I have multiple hypervisors. Everyone's kind of do it. Back in the storage vendor, my background is everyone had a two storage vendor background, right? So they always want to have 2 things, and we see that in the hypervisor space as well. So within our console, you can manage different hypervisors, whether it's in the cloud, on-prem, or a mixed version of that. So that allows you to do that as well. And here, if I'm clicked down to my VM, what I can do is I can see a summary of when it was last backed up, how I can protect it ad hoc if I'm doing a patch, and then I can also recover it at the file level or guest level. And then in this case, this Windows VM is a critical application, so I'm replicating it to VMware Cloud on AWS. So it allows you that ability to do multiple targets as well. If I click here, I'm monitoring in my lab here, I have some VMs going to Azure, some VMs going to on-prem, to VMs going to VMware on the cloud, but I also could do one-to-many. Instead of having one VM go to one DR site, I can do it from on-prem to on-prem if I have that, but also on-prem to AWS or Azure or AWS in the cloud. So you have your hyperconverged infrastructure, so we provide scalable data protection for that. So we bring in our hyperscale to easily scale, so you can deploy our architecture for local data protection and access across the data center. And directly integrated connectivity, like we said. No gateways, it's you natively talk to S3 and Azure Blob, for example. And as you scale your infrastructure, because everything grows today, right? Nothing stays the same. You never shrink data. Very rarely we shrink data. As you grow your infrastructure, we can use our hyperscale to grow as well. So we talked about kind of how we address that issue. But now we're talking about kind of what we've seen in the field. Smarter or faster? How much bandwidth do you need to back up 100 terabytes nightly and have it offsite, right? Do you have any comments on that?
Well, I wrote the slides, so I've got a comment or two. No, it comes back to a conversation we typically see with a lot of our customers in regards to, that's great, I've got 100 terabytes of data in my infrastructure now I need to back it up, right? Any thoughts on what's the best way to protect 100 terabytes of data nightly and then have it off-site? Everybody does it automatically. So are full backups the way to go? No? I still have customers who basically come to us and say, I'm going to do a full backup every night. You must have a really heavy infrastructure budget, right? Or you've put everything on all flash arrays, right? The problem that we see, and this pretty much goes across the industry, is, although there's a lot of great things for hyperconvergence that we see, it starts to have problems in a number of areas on cold and inactive data because you can't cache it all. Right? Now, some of the newer players, when you're talking about all-flash versions of the hyperconvergence, yes, that can significantly help. But now I'll go back to, I hope your storage infrastructure for your networking is rock solid to be able to pull this out. Because a 10 gigabit card can move only about 4.5 terabytes of data in an hour, if memory serves me correctly. That's it. Raw throughput is done after that. And if I'm using erasure coding and replication to pull all my blocks from multiple different 10 gig links, I'm actually going to be limited by that pipe first. Right? Now, when I'm serving data from cache, when I have all of these other data, when the data is hot, I'm not hitting the erasure coding components. I'm not hitting the replication components. I'm hitting locally and serving it up. But if you're asking me to do a full backup, or you're asking any vendor to do a full backup, you're forcing us to reread the entire infrastructure. And that, I did have a conversation with a customer 2 weeks ago that for over a petabyte of virtual infrastructure, their idea was to do a full backup every night. Yeah. So I was like, sure, no problem. I hope you have flash on everything, including us, and we'll totally do that. That's not a problem, right? So, but if we forget about bandwidth for a moment, how fast can a hard drive read? Because not everything is all flash yet. I mean, I'd love to say it is. I'd love to convert everything and just say it's all flash all the time and call it a day. But we don't have the fabs for that yet. And I'll argue that as the hard drive spindles get larger, I don't know if we will in the next few years even come close to that. 12 terabyte, 15 terabyte, 20 terabyte, right? So it's cheap to store a lot of cold data on them, but can I read it fast enough? So, my advice, and this goes across basically, to me it really doesn't matter what product you're using at this point, this is just a fair point of advice, is no matter what you're doing in your infrastructure, incremental forever approaches are the only thing that you should be looking at, especially on hyperconverged. Only read the changed data. There's a much fairer chance that it will be the hot data in the environment and therefore locally cached anyways. But if you're looking at it from the perspective of, I'm going to take a full baseline backup, no matter whose product you're using, it's going to be the slowest. After that, an incremental forever strategy will do you well as long as you have all of the full recovery options from that. Then you only ever have to move it. So if I turn around and I look at that and say, how much bandwidth do I need to do to move 100 terabytes? If I'm at 10 gigabit infrastructure, that's 22 hours. But if I only have a 1% change rate, right, I only need to move 1 terabyte nightly, and then my 10 gigabit infrastructure looks significantly faster. Now we go back to the SLA conversation that Edwin was talking about, and our customers are talking about 1 hour or sub 1 hour, 15 minute. How do I move all of this data into a much smaller SLA window? Well, now if I have to do it every 4 hours, maybe it's only 100 gigabytes of data I'm moving. And then a 10 gigabit infrastructure can do that in a minute 20. You need to look at data protection completely differently than a lot of people still are, and you need to use all the tools that you can. Because otherwise, you're going to be bound by things that are outside of your control.
Now, I think that's a good point. Is changing that idea of how you do data protection, right? The traditional way was fulls, incrementals, and fulls in there. You have to also account for all the changes under the covers too, as well. Think differently in how you do your data protection.
So let's take a quick look at transport methods. Now, SAN mode is pretty much out. For pretty much all hyperconverged vendors, you're done. SAN mode is out. So let's have a conversation about hot add and NBD. Now, show of hands. How many people are using hot add or I'll add in SAN in their infrastructure today for backup? Nobody. One person. Excellent. So we got no backups. What about NBD? Anybody using NBD? Do you like it? We find a number of customers don't like NBD. It's got a bad rap. It's slower per stream than hot add. I have to push all of my changes across the network, and I don't get source side deduplication. A lot of people immediately discount NBD. Now, hot add has a definite perks. It's faster per stream overall. It allows you to get source side deduplication, so you're sending less across the network. But the challenge becomes there's much more operations inside of a virtual or a vSphere environment than NBD. And a lot of those tasks are actually serially driven. So here becomes another challenge point on some of the hyperconverged vendors is when they go under full load, hot add and quiescing starts to fail. And that comes back down to that storage element, not the ESX element. That storage element simply can't do all of the operations when you're relying on the networking and erasure coding and everything underneath the covers. Now, we can add more resources to do it, we can do individual things, but we've also seen that can compound the issue. Now, under full load, NBD becomes actually the better choice. It puts less infrastructure load on it. We're not adding a proxy or anything inside of the infrastructure. We're being completely externally. And with the hyperscale architecture, you can simply turn on individual components and have multiple of those extra components sitting outside and reaching in and grabbing those streams. Now there's another element. NBD has a lot of improvements, so if you haven't seen it lately, you should check it out because it's significantly faster than it was. And again, going back to our previous slide, if we're only focusing on the incremental data, then it's really only the footprint that's changed that you're concerned with. I wouldn't advocate trying to do full-on-full backups with NBD unless you don't let your network admin. Right? Because that's, you've lost source side, so every time you're going to lift it up, you're going to shift it across the network, and then I'm going to tell you if it's duplicate data or not. So that's not the way to use NBD. But predominantly, we see most people today using a source side or using a deduplication technology, and deduplication forever, or incremental forever, really plays well with NBD. As the infrastructure for hyperconverged scales up, you can add more nodes on our side if need be, and you can add multiple ingestion points. Even though the overall stream count per stream might be slower, if I only have to move 100 gigs or a terabyte of data, and I've got 10 gigabit infrastructure, or some of our customers are now showing us 40 gigabit or 80 gigabit if it's bonded infrastructure, moving a couple hundred gigs of data is easy peasy. Right? We're long since past the day that I'm like, oh, I have to move 100 gigs of data. I'm like, I can do that at home. Right? So don't discount it, and if you haven't used it lately, I would retry it because VMware themselves have made some serious improvements to it also. Because they see some of the shifts that are out there, and you can't just have a one-size-fits-all. It's also the lowest common denominator in all protection configurations. It's the only one guaranteed to work no matter what architecture, storage that you are using. So if you have some hyperconverged in your environment, and you have some that's maybe on NFS and some that's on fiber channel and throw in all these protocol mixes, guaranteed the only thing to work every single time will be NBD. And if you want to have a large pooled infrastructure behind it that will auto-configure and manage it, you can use hot add. Conversion infrastructures, you can use SAN too. But hyperconverged, you're usually on the 2, and it's a little bit of buyer beware.
Great. So kind of in closing, here we go. In terms of our blueprint for hyperconversion in hybrid cloud is that with a single data platform, we can do all these things in your environment. We manage multiple hypervisors. We do lifecycle, live recovery. We can move data to the cloud, different tiers. We support all 30 plus cloud vendors. We can replicate, do your disaster recovery in the cloud, on-prem. So we give that within a single tool. We give you all the things that you need to do to protect your environment, whether it's on-prem protection, disaster recovery, a full life cycle of your VSA for your VMware or whatever hypervisor that you're using in your hyperconverged environment. So what's our value proposition? It's flexible virtualization protection. regardless if you're hyperconverged, converged, or traditional, right? We don't just migrate into hyperconverged. It's a slow step, so you have multiple environments to manage. So we have that flexibility, simple deploy and manage, web-based. Gives you that ease of use, but also ability to kind of give self-service to other users. DR ready, we talked about, is we can use that backup to give you your disaster recovery options that you need. And then cloud ready, natively talking to cloud, whether it's at the as a cloud target or as a location for disaster recovery, or even conversion from converting VMs to AWS or Azure. We do that as well, built into the product. And kind of what Jonathan touched about apart is we cover the whole enterprise. The hyperscale environment, direct cloud integration. We support converged cloud service providers. If you have workloads in the cloud that you have for dev or other production workloads, you can manage it within the single interface. Traditional infrastructures, hyperconverged, and scale infrastructure. So within our platform, we support all of these major applications and environments with a single interface.
Questions?
Questions?
All right. Well, thank you very much for attending then. And if you have any questions, you can come up and talk to us, or otherwise, have a great show.